to inform or to understand chemical stability better. Moving on to chemical stability, I want to look back at our stability diagram that we had up before. And the reason that this is important, because you have to think about, is your powder delivering maybe the health benefits that were promised? Is the vitamins, are they there that you promised, or has there been some type of chemical change that you need to be aware of? And if you look at that stability diagram, there are different points in that diagram where degradation rates or reaction rates are going to change. For example, around 0.6 water activity, you might have an increase in Browning reactions. At very low water activities, this is where we see lipid oxidation start to increase. And so you just need to be aware of how water activity is affecting reaction rates and maybe which reactions are related to an end of shelf life. So I know that you recently worked on a vitamin C experiment and looking at how it relates to water activity. Can you explain this experiment and what you found?
Yeah, so chemical reaction rates are a little more complicated to track, but if you can track them, and that is doable, to be able to track the reaction rates, we can use that information to predict a shelf life and a timeline, essentially, to when they've reached a point where we'd consider the shelf life ended, right? So our study was on ascorbic acid. And basically, we exposed it to 2 different water activities and 3 different temperatures. And then we tracked how it degraded using UV vis, and we're able to calculate those rates. One of the parts that's critical about this is we were using the Arrhenius equation, which is very common to use for this type of reaction. So basically, you're going to connect a rate to a temperature and an energy, right? So we already know when we talked about energy, we can relate that to water activities specifically. So basically, we run a study where we're starting at time 0, and then over a period of several days to weeks, we've gone and exposed that ascorbic acid to a specific humidity and temperature, and then we watch it change, and then we can graph it. So this is our study. Essentially, we would like to know how temperature and water activity are going to affect the degradation rate. So we've got these time plots here that we're showing the graph. So we have our water activities were 0.76 and 0.948. Then the temperatures that we used, and we are running this as a little bit of an accelerated study. So we have 30 degrees C, 40 degrees, and 50 degrees C. So essentially, we put this into the calculator, and we use the Arrhenius equation to help draw the information and correlate everything. Once we get all our data in, our study data in, then we can tell the program specifically what our interest is. So what temperature are we interested in? What water activity are we interested in? And then we also need to define in the study where we're going to end shelf life. So what percent is left? And in our case, what we did was we decided that 75% of the vitamin C left would be the end. So we would essentially lose 25% of our vitamin C, and then we would call that the end of shelf life. So like if you're a formulator or a manufacturer, if you have like a vitamin like you were talking about, you have claims for so much, vitamin or the potency of your product. So you would base whatever ended shelf life on that value, right? So once we can put all that information in, then it can calculate a shelf life. So in our case here, with our ascorbic acid, if we were interested at 30 degrees C, and we were going to have it around 0.8 water activity, which is pretty high. A bathroom could be that, though, right? So, which is relevant to about 80% relative humidity. And then, like I said before, the 75% is going to be the end. We would have 62 days before this ascorbic acid was no longer potent enough. So that's basically how the chemical stability works. So we just need to track it. And if you're able to measure that, then you can do this study.
And again, this is another tool that we have in the moisture analysis toolkit that we built specifically for chemical stability. And even though it does take some time to gather data, I mean, I'm sure it took you a while to gather all of the data, but once you have that data collected, it's really easy to graph in the toolkit. And like you just showed, you can put in, in a starting water activity, a temperature of interest, and then define what's ending your shelf life and quickly get calculations. So even though it may take some time to set up a study, and these are studies that we can do or we can also guide clients through using humidity chambers, once that data has been collected, there's a lot of flexibility with the calculations and a lot of insights that you can get. And so, we were looking specifically at vitamin C in your case, but this could be really for anything that we can measure, right? Anything that we can assign a value to.
Right. And it goes both directions. So it could be, in this case, this is the degradation, but you could do an increase of something, right? As maybe a browning reaction or something like that increased over time. And then that's what ended shelf life. It was maybe a specific color value. It doesn't really matter as long as you can measure it. So if there's some way you can actually track that change, then you can turn it into a rate and you can get plots like this.
Mm-hmm. And there's so many nutritional supplements now and so many things are in powdered form that using this type of tool could really help them understand maybe what their water activity target is or shelf life conditions or, what does end their shelf life, what % of losing a certain vitamin, or how can they make that claim that's on their label? How do they know for sure? And this is a really good way to do that.
Right. And again, like the example before, you could, change your interest, right? You could change your temperature and your water activity of interest, or even how much you want at the end, right? All of that is just easily to be changed and just reran the prediction.